Chemical bonding explains how atoms combine to form molecules and compounds. Atoms form bonds to achieve stability, usually by completing their outermost electron shell. This concept helps explain the formation and properties of different chemical substances. 2. Octet rule. The octet rule states that atoms tend to gain, lose, or share electrons in order to achieve 8 electrons in their outermost shell. This configuration is similar to noble gases, which are stable. Many chemical bonds are formed based on this principle. 3. Types of chemical bonds. There are mainly 3 types of chemical bonds. Ionic bond, formed by transfer of electrons from one atom to another. Covalent bond, formed by sharing of electrons between atoms. Coordinate bond, formed when one atom donates both electrons for bonding. These bonds help atoms achieve stable electronic configurations. 4. Ionic bond. An ionic bond is formed when one atom transfers electrons to another atom. One atom becomes positively charged and the other becomes negatively charged. The attraction between these opposite charges forms the ionic bond. Example: sodium chloride, where sodium loses 1 electron and chlorine gains 1 electron. 5. Covalent bond. A covalent bond is formed when 2 atoms share 1 or more pairs of electrons. This type of bond is usually formed between non-metal atoms. Example: in hydrogen molecule, 2 hydrogen atoms share electrons to form a stable molecule. 6. Lewis structures. Lewis structures represent molecules using dots to show valence electrons. These diagrams help visualize how electrons are shared or transferred between atoms during bond formation. Lewis structures help understand molecular bonding and electron distribution. 7. Valence shell electron pair repulsion theory. According to VSEPR theory, electron pairs around a central atom repel each other and arrange themselves as far apart as possible. This theory helps predict the shape of molecules. Examples include linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral shapes. 8. Hybridization. Hybridization is the mixing of atomic orbitals to form new hybrid orbitals. These hybrid orbitals have equal energy and specific shapes. Common types of hybridization include sp, sp squared, sp cubed, sp cubed d, and sp cubed d squared. Hybridization helps explain molecular geometry. 9. Molecular geometry. The arrangement of atoms in space determines the molecular geometry. Different molecules have different shapes based on the number of bonding and lone pairs of electrons. Examples include linear shape, trigonal planar shape, tetrahedral shape, and pyramidal shape. 10. Molecular orbital theory. According to molecular orbital theory, atomic orbitals combine to form molecular orbitals that belong to the entire molecule. Electrons fill these molecular orbitals based on energy levels. This theory helps explain bonding in molecules more accurately. 11. Hydrogen bonding. Hydrogen bonding is a special type of weak attraction between hydrogen and highly electronegative atoms like oxygen, nitrogen, or fluorine. Hydrogen bonding affects boiling points, melting points, and properties of substances such as water. 12. Importance of chemical bonding. Chemical bonding explains how molecules form and why substances have different properties. It helps understand chemical reactions, molecular shapes, and behavior of matter. This concept is fundamental to chemistry and many scientific applications.